Okay, this is the last lesson in our entire unit on dealing with graphs of quadratics, and it's been a marathon recording session for me. It's like the 5th lesson in a row that I'm recording, so hopefully I'm still coherent. I apologize if I'm not. This last topic is on writing specific equations for given, for a parabola that has to have a vertex in a certain spot and it needs to go through a certain spot. So before I kind of get into this, I want to give you a sense of why would somebody want to do this? Why would this be important? So remember the shape of a parabola is this. It's kind of this arc. And there are parabolas all around you. And the most common application for a parabola is something called projectile motion. Okay, now you might have heard of the expression projectile vomit, okay, which is nasty. But the idea, projectile vomit is when somebody launches, they throw up and it arcs across and it just goes across a room or something. That's the idea. Projectile means to throw or to drop something. Usually when I do this in class, I will throw something across the room, whether it's a ball of trash or a marker from my whiteboard, because when you throw something, it actually follows what's called a parabolic arc or a parabolic trajectory. It's not sort of like a parabola. It actually is a parabola. When you see a water fountain and you go to where I'm from, we would call a bubbler, okay, and you press the little button, the water comes shooting out in a parabola. So there's actually lots of applications for this, and when I took physics, if you guys go on and take physics, you will do a lot of projectile stuff. But it was always bombs. For some reason, we were always bombing stuff. And so bear with my poor artwork here. This is a plane, okay? That's a plane, and this is the target. Okay, and we could make this better. We don't have to say it's a military target. We could say maybe they're dropping food and you want the food to land in front of the hospital where the needy children are, okay? But it's the target, so we're going to drop something. When you drop stuff out of the plane, it does not fall randomly. It falls in a parabola. So you might have the vertex of the parabola be here, and this is the point that you want the parabola to go through. And so in order for the pilot to know when to release the package, the care package, or the bomb, okay, you need to know where these points are, and you need to know exactly what kind of arc or parabola this is going to look like. Depending on the height of the plane and the speed of the plane is going to control whether you have a skinny parabola or a fat parabola. And of course, there's more things in there like air resistance. Does the projectile have a parachute on it, or are you just going to drop, a bag of fruit down on the village or whatever it is? But the idea is that you have the vertex point and you have the point where you want it to go, and you need to be able to mathematically analyze this. Now, whether the pilot, him or herself, is the person that's doing it, probably not. But somebody did. Somebody had to program the computer. Somebody had to know what all the variables were and what they did. So I want to introduce with that just because I want you to realize that there are situations where you would need to come up with these equations. You might not ever do it in your career, whatever you decide to do, but somebody does it, and for that person, it's an important skill. So it's not this totally useless thing that we're doing. So let's take a look at the first. I actually only have one example here, and then a practice one for you to go through. We are going to write the equation of the parabola with a vertex at -2, 4, and going through the point 1, 2. Now, this was not this particular problem, but there was a problem like this that was a bonus on the activity from Friday the 23rd. Okay, yeah, on Friday the 23rd, and I know at least one person in period 6 was able to do it. I gave you a hint. We did, when we were writing equations for lines, we were dealing with y equals mx plus b. And do you remember how we borrowed the x and the y? That's the X and the Y. It's the same idea. So take a moment and think back to when we were doing that idea of borrowing the X and the Y, because that's what we're going to do here. We're going to borrow an X and a Y to figure out something, and then we're going to give the X and the Y back. When we did it for lines, we calculated the slope, we borrowed the X and the Y so that we could find the B value, and then we rewrote the equation. And you can go back and find that video. They're all on YouTube, so you can go back and find it. Same strategy here, except instead of dealing with y equals mx plus b, which was our line, now we're going to deal with the equation for a quadratic, because it's a different family of functions. So a different family of functions means we have like a different template to use. Remember that H and K are the vertex. So we've got some information here. We know the vertex is -2, 4. That means that H is -2 and K is 4. We also have the point 1, 2, and we want it to go through the point 1, 2. And that's where we're going to get our X and our Y that we're going to borrow. Now, think about this for a moment. There's like a couple ways you could reason this out. If the vertex is at -2, 4, it means it went left 2. And you know that left 2 is going to translate into a +2 when you put it over here in the equation, because +2 means it goes left. I'm not going to do it quite that way, but I want to point that out. Like if it goes to -2, it means you had a +2 on the inside here. All right, so let's go and plug some stuff in. We like to plug some stuff in. We have a number for y. We're going to use a 2. I do not have anything over here that corresponds with the a, so we're going to leave the a alone. I do have a number that I can use for x. I can use a 1. I have a minus sign. Bring it down. H, I do have a number I can use for h. That would be -2. And I have a number I can use for k, which is +4. Now I'm going to do, I don't know why I changed colors there. That was kind of weird. Sorry about that, guys. Now, none of us like minus a negative, like none of us do. But remember, subtraction just means adding the opposite. Now, about a minute ago, maybe 2 minutes ago, I said, remember that when you have it going left 2, you're going to end up with a +2. Where that +2 comes from is from doing minus the negative. Okay, so you're welcome to jump straight to the +2 there. You don't have to go through minus and negative. I just want you to see that it's consistent. I know I harp on that all the time. Math is consistent, math is consistent, math is consistent. So the stuff that we learn about going left 2 and having a +2 matches up with like using the numbers on the signs and doing like minus a -2. Like it should all come out. Now, just like when we did this for lines, we borrowed the numbers so we could find the value for B. If you look at this, the only number we don't know is A. So what we're going to do is basically solve this equation to figure out what A is, and then we're going to give back the X and the Y and rewrite the equation with the H and the K. So using order of operations, we start with parentheses. So 1 + 2 is 3. 3 squared is 9. Now, I am switching the order there. I'll kind of slow down there. I had 3 squared, which is 9. And so I have a times 9. But that's a little uncomfortable for us to write a times 9. And so I switched the order to 9a. It's just a more comfortable way to write it. I want to get the a by itself, so I'll subtract 4 from both sides and get -2 equals 9a. And then I'll just kind of creep up here. -2 equals 9a. And then we divide both sides by 9, and I get -2/9 equals a. Don't freak out over that, okay? Don't freak out. Now I have my value for A, and so now I'm going to give back the X and the Y. Oops, I accidentally dragged my whole thing around and paused the video for a second. Hopefully that was smooth. I'm going to give back the x and the y. Why do I have like a frozen pointer there? And rewrite the equation. So we would have y equals, and I'll rewrite this just so we have the template. I'm giving back the y. I know that a is -2/9. Give back the x. Now here you can do minus -2, but remember that's going to end up being a +2 and +4. We're going to keep the +4. And I'm done. And there's my equation of my parabola that goes through the point 1, 2 and has a vertex at -2, 4. And you can check that vertex. You can check that using your transformations. You know this goes left 2 and up 4. And so left 2 up 4 would put you right there, which is the point -2, 4, which is what we knew the vertex was supposed to be. So you can always do that. If that like plus minus in there kind of bugs you, you can always do a little check there because you can fall back on what you know about transformations. All right, so I'm going to give you guys one to practice on, and then that is going to wrap up this unit, and we'll start talking about review day and test. So I want you to do the following. Write the equation of the parabola with vertex at 3, -2, and going through 0, 2. I'm not sure how I'm going to have you do this. I might have period 3 do this on Go Formative, just so that we can like take a look at the work and see what people are doing. And but I don't know yet, so we'll find out. For those of you that are reviewing or watching from home to study, just pause the video and I'll go through this practice problem in a moment. Okay, so this is our template. So instead of using y equals mx plus b, we are using our vertex form for a parabola. I know that my vertex is at 3, -2. So that means h is equal to 3 and k is equal to -2. And I want it to go through the point 0, 2, so x is equal to 0 and y is equal to 2. I love zeros. I love zeros when they turn up in problems. Like, it's just the best thing ever. So let's go ahead and like throw all those numbers in over here where they belong. So y equals 2. A is what we don't know. X is 0. H is 3. You don't have to worry about like the double negative there. That's always nice and not have to worry about that. And then k is -2. This 0 minus 3 is -3, and -3 squared is 9. And I'm going to add 2 to both sides to get 4 equals 9a, and divide both sides by 4. So a is equal to 4/9. And then my last step is to rewrite it. We're going to give back the 0 and the 2. And keep the h, keep the k, and then we'll have the a values. So we'd have y is equal to 4/9, x minus 3 all squared minus 2. And there you go. All right, so fairly short lesson. Last one, hopefully that's a good thing. And we will move into preparing for your test on graphs of parabolas.